All right, so the first exception to the octet rule is the odd electrons. And so here, when you have an odd amount of electrons, you're going to have an unpaired electron. So if you think about an orbital, you're going to have an electron without a pair. If you think about the Lewis diagrams, it looks something like hydrogen here. And so whenever you have an unpaired electron, this is also called a radical or a free radical, but most of the time just radical. I did a lot of my PhD work studying radicals, so I'm pretty familiar with this concept. These are generally reactive slash unstable. So they do exist, but they're relatively unstable. So that kind of makes our model look good. It is an exception to the model, but it's not that stable, so not bad. So NO is an example of this, nitrogen monoxide. If you think about valence electrons, this one has 11 valence electrons, nitrogen 5, oxygen 6. So draw our Lewis structure, NO, down to 9 valence electrons. So we'll put 6 around oxygen, and then we have 3 left. So we'll pair one up and then one by itself until we have 0 valence electrons. And then we think about trying to get everything to have an octet. Right now, nitrogen only has, let's see, 5 electrons, so we could donate it another set of electrons. And now nitrogen has 7 valence electrons. So if we try to donate another pair to go over the octet rule, as we learned before, nitrogen and oxygen, they can't break the octet rule, but they can have less than an octet. So this is the correct Lewis structure for this compound. And if you think about it, it does kind of make sense. If you think about the formal charge here, nitrogen normally 5 valence electrons minus 3 non-bonding minus 2 bonds has a formal charge of 0. And this oxygen also has a formal charge of 0. So even though it's an exception, it still kind of makes sense. We still have our formal charges down as low as possible.